All right, for this bell work, it wants the y-intercept. And remember, the unique thing about our y-intercepts is that as an ordered pair, the x value is 0. So, in this equation where it gives me an x, I know I can replace it with 0. Okay, the rest of it, this equation doesn't really change. 10 times 0 now minus 30y equals 15. 150. There we go. But I do know that 10 times 0 is 0, so all I'm going to do with that term right there is just make it a phantom 0. Okay, so it's still there, you just can't see it because its final value is 0. And then the last thing I want to do to find the y value is just divide both sides by negative 30 to make the coefficient of y a phantom 1. Okay, so it can show 1y for now. And then 150 divided by negative 30 is negative 5. But now that I got that answer, I can make that one a phantom 1, okay? So its corresponding y value for y-intercept would be negative 5. Of course, your x value is just always 0. This is the y-intercept. This slide is just showing us that ordered pairs can be arranged in a table for a relationship like this. Of course, we know that it's possible to write an equation for these types of ordered pairs like this. Remember, if you can find the slope and the y-intercept, like this one gave us the y-intercept right here. We know that because the y value or the x value is 0. Okay, so we know that this ordered pair would be the y-intercept. After this, you just need to find the slope. And even though this gives us 1, 2, 3, 4, 5 different ordered pairs, you really only need 2 ordered pairs, as we know, to find the slope. Okay, because we would use the slope formula where you'd have x values in the denominator, y's in the numerator for both ordered pairs. So when you see 5 ordered pairs or just more than 2 ordered pairs, just know that they're giving you more information than you need to find the slope, okay? But you can even see for the tables, right, they got an x column and y column. That means that each of these pretty much just goes directly into an ordered pair like this, okay? It's just a different way to show ordered pair values. Now, if by chance they gave us an equation, I know they didn't on this one, but if they did, what they may do is say, look, we don't know this y value, but we are asking you to find the y value when this x value here is 2. Okay, and they can do that the other way as well. They can say, look, now we know the y value, find its corresponding x value that would make whatever equation it is, whatever it is, would need to be true. Now, the other thing about this is you can see that some tables are lined up this way, okay? So it's the x's that are usually in this top row, and then the y's are usually in the bottom row, like this, okay? So I believe you guys saw some of this in 7th grade. If not, and this feels pretty new because we forgot everything in 7th grade, that's pretty normal too, okay? But you're going to need to understand when you see a table of values like this, that it's really telling you that you're looking at some ordered pairs. So here's what a function is, and this is the name of the unit is functions. But a function is when each input, which is an x value, has only one output, okay? And you're gonna want to know this output answer right here. So I'd say, I don't know, take 30 seconds to copy this down because you're gonna want to know it for the assignment, okay? Now here's what this means is if you look at ordered pairs, and hopefully we feel pretty familiar with these ordered pairs. You got some kind of x value and then a y value like this, right? What we're saying on this is that the x values are what we call input values, and then the y values are output values, okay? So if that's input and output, then what this tells us is that if you have an equation, the equation is a function. So if we look at something that maybe we're kind of familiar with, something like y equals 2x plus 1, something like this, okay? So we can see the y-intercept here is 0, 1, and then the slope would be up to the right 1, okay? But what this is saying as well is that essentially this becomes kind of like a machine. So back in the day, they used to show this with some kind of conveyor belt right here, and then you'd put something into the machine, that's input, and then up here they got another conveyor belt which tells you what comes out of the machine, that's output, okay? So here's what I mean by this is, if you, let's say that you put in, I don't know, 4. If you put in 4, then that would be your input, so that as an ordered pair, you'd have 4. But now you gotta put this x value that's 4 into the machine, right? So then you say, now x is 4, 2 times 4 is 8, plus 1, and then what do you get out? 9. So that would give you the ordered pair 4, 9. And yeah, there used to be some animations with this, but I hope that really doesn't matter at this point because we're kind of older than that, right? So input and output, that's kind of what it's talking about. And functions, when we say something is functioning or is a function, it's functioning like a machine would function, right? You put it in and then out spits something else. Okay? In other words, it should be true, it should always be true. And it should be true, it should have been true yesterday, it should be true today, and it should be true tomorrow. All right? We refer to that something else when it's not mathematics, but in mathematics, that means we're talking about something that is functioning, okay? So let's change this up just a little bit because that was a function, right? Now, yeah, let's say we still got an input right there. Okay, but let's change this up a little bit for us. So let's change the function. There we go. All right, so let's say that I come to this machine here. I don't know really what it's doing on the inside, but I know that I'm going to put in, I don't know, 5. You know what? I'm going to go with 4. Nah, we did 4, right? 2. I'm going to put in a 2. And then we get this ordered pair, right? 2, and then out comes 7. For some reason, 7, okay? So this gives me the ordered pair 2, 7. All right, and that was fun, and it feels good, and it smells good, okay? But the next time I go to this machine, what do? I put in a 2 again, but now when it spits something out, it says, oh, I'm gonna give you a 10 back, so 2 and 10. Now, I can't really know what this function is doing, or what this machine is doing. See, right here, the last time I came in and put in a 2, it spit out a 7. But now I'm putting in a 2, and now it's spitting out a 10. So at this point, I would say this machine is malfunctioning, which means that as soon as I see these 2s like this, but the y values don't match, I can immediately say that this is not a function. See that? So let me emphasize this without numbers because sometimes this helps us make sense of this. Okay, so let's say this is some kind of microwave right here, and I put in breakfast burrito. It's about that time of day, right? Try not to think about it too much because it can distract us, right? Here's a microwave, I put in a burrito, and then when I open the door here, it says, hey, here's a burrito, but it's nice and warm. And it has bacon in it with eggs and cheese and all the other fixings. Hey, that's pretty good, right? And we feel pretty good about that. But the next time I go to this microwave, I put in a burrito, and when I open the door, it's showing me a pizza. Okay, now I should expect to see a burrito, right? Because last time I put in a burrito, it gave me a nice warm burrito. But now it's like, here's a pizza, dude. And so, I mean, never mind the idea of nuking things, but now it's like, holy crap, this is not working very well at all. And either you take it back to the store because it's malfunctioning, or you use it for target practice. So, but that's the idea with this function business, is when you put something in, you need to know what's going to come out. If you don't know what's going to come out, like, hey, that time you put in a pizza, what if the next time you come in, you put in a burrito, and then out comes some walnuts? It's like, what the crap is going on over here? You know what I'm saying? So, but that's what we're talking about when this is a function. That's essentially what this is saying, but just with numbers, okay? So just to kind of emphasize this, we got two sets. Now this is a different way to show sets right here. It says the following sets of ordered pairs represent valid functions. So let's look at R first. We'll come back to S. But for now, let's just look at R. And remember, for every X value, you should have only one individual Y value, right? So I look first at, let's look at -4. And -4 has a Y value of -1. Is there any other evidence in this ordered pair set that says something otherwise? No, because there's no other -4s in this set. So I know this one checks off. Okay, so that one checks off. What about 1/8? Well, again, look at the 1. And now look at its corresponding Y value. The 1 is the X, that's the input. And then the 8 here is what's coming out of the machine. And again, there's no other evidence to say, well, if you put 1 in, that you'd get something else out. Okay, so this one also checks off. Well, what about 5/8? Well, 5 is the X value, that's the input, and then 6 is the Y value, that's the output. But again, there's no other values here that show that if you put in 5 into the machine, that you're going to get something different out. Okay, so this one checks off. How about 7/8? Well, 7, again, when I see a 7, it only spits out an 8 right there, so that's going to check off too. And then also at the end here, of course, 16 is by itself, and it's only going to spit out a 10, so this one checks off. That means that this function R, or this set of values for R, we would call that a function. I don't know, a function, okay? So on the second set, S, right here, okay, so we got, we're gonna put in a, use the color, we're gonna put in a -3, right? And then what does it spit out for this set? It says, you put in a 3, out spits a 0. Now, is there any other evidence? Again, you're looking for any other evidence to show that when you put in -3, that it's not going to give you 0. And so we go down the line, that's a 3, that's not a -3, so that's not the same. Here's a 6, there's a -3 right there, okay? So this one's saying, look, you put in a -3, out comes a 2, what the crap? Okay, that means that this now is unpredictable, this machine, whatever it is, it's no longer working, right? Remember, you put in a burrito, out came a burrito, hey, that's pretty good. Over here, you put in a burrito, out comes a pizza, what the crap? So this one right here, S, this one, not a function. And so it really is, especially when you're looking at ordered pairs like this, it's pretty much that simple. You're looking for X values that repeat, but they spit out different Y values. Now notice I did not look at any of the other ordered pairs because I don't give a crap. Because I just found that right here when I put -3 in, it gave me a different Y value. This is looking at this through ordered pairs, but you're going to want to think about how this would work in a table, right? Because that's what we saw in a couple slides ago there. How would this look in a table? But the idea is the same. And then think about how that would look on a graph. For equations, we're not really going to go into that in too much detail. For functions, but definitely ordered pairs, tables, and graphs we will. All right, now we got a little bit more vocabulary here. The domain is a list of the X values, okay? So domain, that's our X values. Again, we call, when we're referring to functions in mathematics, we call the X values what you put in, the input. The Y values is the range. Y values is range. Remember, when we're referring to functions mathematically, we don't necessarily call those Y values. I mean, if you talk to a really nerdy math person, they won't, they'll be like functions, yeah, you got input and output instead of X values and Y values, but they mean the same thing, okay? Now in these sets, like we saw on that last slide, if there's any values that repeat in these lists, whether it's for the domain or the range, we do not list them more than once, okay? Now, I know this is new, so you're like, what the crap are you talking about? So these lists, so the domain, usually I just represent it with a D, because writing the whole word domain isn't very fun. And we use fancy brackets like this. And then we just put whatever numbers in between these fancy brackets. And yes, you do have to use fancy brackets, because if you don't, it's just not fancy enough and it freaks math people out. And then you just list whatever goes in between here, all right, for the domain. And the range is pretty much the same thing. You're now, if you're concerned about how to make these fancy brackets, when you want to open up a set of fancy brackets, just an S, and then a 2. I know that's not as fancy as the other set. I can try that again, because I'm a math nerd and it kind of bothers me. So there's an S, there's a 2. That's good enough. Okay, and I can come to the other side to close this up. It's just the opposite. So just put a 2 and then an S. Boom. Fancy brackets. Maybe they don't align very well, but okay. There we go. And then we're just going to list the values. Again, the domain, that's just a list of all the X values that it gives you. And then the range is just a list of all the Y values that it will give you. So on this problem, yeah, we'll determine if it's a function here, but first, domain and range, okay? So once again, I'm going to start with my domain. The domain I'll just represent with D, fancy brackets. So there's an S and then a 2. But I'm just looking at all the X values. So I got -5, -4, -3, -2. So I'm just going to list these. And the order doesn't necessarily matter, but I believe on the assignment it wants you to list them in order from least to greatest, okay? So that's what I'm going to do for this one, just because the assignment will do that. So the lowest one is -5. And be careful if you're like, well, -2 is the smallest. No, it's -5 because we're looking at all negative values here. Then we have -4, then -3, and then -2. That's all my X values, so now I can close this up for my domain. It's a list of the X values. I'm going to do the same thing with the Y values, but that's called the range, okay, the output. So fancy brackets, S, and then 2. Okay, so I'm looking at all my Y values, -5, -5, -4, -4. So again, if it repeats, I'm not going to list it twice, right? Like, because you got -5 and -5. But don't list this more than once, okay? Because if you do, it's going to mark it incorrect. So that, by the way, is the lowest value of the Y values. The next one is just a -4. And again, I'm not listing that twice, but I do need to close this with fancy brackets. That's a 2 and then an S. Boom. Here's my domain and range. Now, this is asking, finally, is this a function? Because we've listed the domain and range. But is it a function? Well, that's a good question. Is there any evidence to show that it is or is not a function? Now, see here, I put -5 in, out comes -5. That's good. Okay, remember, you have to start with the X values, not the Y values here, to determine if it's a function. Right here, I put in -4, out comes -5. Again, there's nothing else to prove that if you put in a -4, that it's going to spit something else out. So yeah, that's good. Same with the next set. Here you're going to put in -3, it spits out -4. There's no other ordered pairs to show anything different, so that's okay. And then finally, this last one, of course, there's no other -2 X values, so that one's going to match. That one's good, okay? So is this a function? Yes, it is. Yes. I don't know, maybe it should say, yeah, a function. I believe on the assignment, it's just kind of a multiple choice thing for you, function or no function. Here's this one. Find the domain and range of this relationship. You guys try this one out. Take 1 minute, try this one out, then we'll go over it. So let's start with the domain on this domain. And again, we got some fancy brackets. There's an S, there's a 2. So I'm going to start with, again, the domain. That's all my X values. And I see my first X value is -2, okay? So I'm going to put that into my domain. And the next X value, well, it's -2. Now, you don't have to list that a second time. In fact, you shouldn't. So I'm not going to, okay? But then the next X value also -2, and then finally the last one also -2. So there's only one X value in the entire domain here. So there's a 2, there's an S. That closes our fancy brackets. Next up, we got the range, which again is the Y values. There's some fancy brackets, not so fancy, but good enough. And again, these are Y values. So what are my y values? And again, we want to list these in order from least to greatest. But yeah, all my y values, 6, 5, 4, and 3, the lowest of which is 3. So there's a 3. Next lowest would be 4. It just kind of goes backwards there, 5, and then 6. And then I'll close this off with some fancy brackets, okay? Well, is this a function or not? Well, here, see, remember, go to the microwave, you put in a -2, out comes a 6. All right, hey, that's pretty good. The 6 tastes good. Next time you go put in a 2, out spits a 5. What the crap? And not only that, but next time you go, you put in a -2, a 4, and then next time a 3. And so it's hard to know if you put in -2 into this machine, whatever it is, you'll never know what's going to come out. And of course, you know some values that could, but you can't really know for sure which one will. So this one we say is not a function. So here's our table stuff, and it wants the domain and range, and then we'll figure out if it's a function, okay? But remember that each of these is by itself an ordered pair, right? In fact, I'll try and use a different color here, but -5, 2, that's an ordered pair. -3, 4, that's an ordered pair. -1, 6, 1, 8, and then -3, 10, okay? So let's list the domain first here. Domain, fancy brackets, S, and then a 2. And my first x value, remember, these are my x values. I got -5 here, so I'm going to list that. Oh, it's also the lowest one, so -5. Then we got, looks like the next lowest will be -3. Now we got a couple of those, and that's okay when I'm listing the domain. So I'm not really thinking if this is a function or not yet. But once you get enough experience, you'll know pretty quick if it is or not from a table like this pretty quick, okay? The next lowest value I see in my x value is -1. And then finally, the last value here is just a 1, okay? So that's in order from least to greatest. There's some fancy brackets. Okay, so we got 4 different x values, even though there are 5 ordered pairs. That should say something to you, especially from what we saw last time. So let's list the range, and again, this is just the y values. Let's give ourselves some fancy brackets. And so the first, looks like the lowest y value got in here is 2. That's good. So I'll list it. And then 4, then 6, 8, and 10. So this one was nice. Went order downwards from least to greatest. 2, 4, 6, 8, and then 10. And now that I got that, I can close my fancy brackets. Now the range has 5 values, whereas the domain has 4 values. And even just from that information, you can tell pretty quick that this one is not a function, okay? Now, again, that may take some time to really understand that. So let's go back and kind of look at what we've been doing. So I say on this one, see, we got this -5 here, but there's no other -5x value. So when you put in -5, it spits out a 2. Hey, that's good. The next value, though, -3 here, when I put in -3, it spit out a 4. But now down at the bottom, when I put -3 in, it spit out a 10. Again, this is another reason why this is not a function. So, and if you can just stick with that, it should be pretty clear when a relationship is a function or not. But if you can see it through the domain and range as well, then that can help too. Okay. So now it just gives us a graph, and these are all ordered pairs. So it may even help to just list the values of each ordered pair. Like A here, that would be 1, 2, 3, 4. So it's 4, and then up 3, 4, 3. B here looks like it's 4, -3. And then C looks like it's 3, -4. D is -4, -3. And then finally E here, -5, 3. Okay. So for all these ordered pairs, let's list the domain first. And again, the domain, that's all of our x values. So the lowest one I got here is -5. How do I know that's the lowest? Because I'm really just scanning this graph going from left to right. Okay, so E is furthest to the left, and I got a -5 x value there. So there's -5. Next one I run into scanning from left to right is D, which is -4, -3. I just want the x value for now. Then the next one I run into is C right there, and that has an x value of 3. So there's 3. And then finally, A and B have the same x value. And remember, that means something for a function, okay? But we'll get to that. There's my domain, even though, again, there's 2 4s in my x values. I only listed once. And now I'm ready for my range on this. Something like that. So the range, when I look at a graph, I'm scanning it from bottom to top because I want to list these from least to greatest, okay? So bottom to top. And the one the furthest downwards looks like it's -4 there. So -4. And then, yeah, we got a couple -3s, but I only listed once. And then scanning upwards, we got the same y value again as 3. So just from this information, looking at the domain and range, I couldn't tell you for sure if this was a function or not. But we can tell through the ordered pairs. But this is our domain and range. Is it a function? Well, is there any place showing that if you put in an x value, you get different y values? And yeah, there's a couple right here. 4, 3, and then 4, -3. So whichever one you do first, maybe you put in a 4, you get a 3 out. Hey, that's fine. But next time you put a 4 in, you get a -3 out. That's no good. Okay, the y values would have to match. Of course, that would just be the same point, but where the y values do not, this one is not a function. Okay, now there's another way to tell this, and I'm going to show it to you right now, even though we're going to go over it a little bit later, okay? On a graph, it's so easy. As long as you can draw any kind of straight line or find a way to do it with a straight line like this. Let's see if I can get this to work. Okay, so I got this straight line up and down, straight up and down, okay? If you scan your graph, you're just looking to see if there's ever any 2 points on this line. See this vertical line right here? And it's pretty, and it's purple. But see, if I scan this, I get E, but there's no other point on this line. So, okay, that's good. D, yeah, D's on the line down there, but there's no other points on the line. Further scanning, I get C, but no other points on the line. It's only when I get here, see that? You got A and B. If there's ever a time where there's 2 points touching this vertical line, then it's considered, again, not a function, okay? We're going to get more into the graph stuff here in a little bit, but just understand that that's coming, and there's kind of a formal name for it, but you can call it whatever you want. We'll get to there. All right, mappings and functions. Okay, so a mapping is just a different way to show ordered pairs, okay? So right here, you got these ordered pairs, 0, 2. See how it's just showing this ordered pair 0, 2 because 0 points to 0, 2. And whenever you get a mapping like this, the left side of the map here, that's the input. That's our x values, right? So, do whatever one you want. And then the right, column right here, that's our output, which again is just y values, okay? So that's why essentially these become like ordered pairs right here, 0, 2 or 3, 8, these other ones, okay? So just understand that we're going to be seeing these in this unit. So sometimes, this, by the way, it's a table. It's now called something different, and it looks a little different, okay? Now down here it says, when are mappings functions? Well, think about this. If we made this, let's look at this table right here. What could we do to make this not a function? Because right now it is, right? You just have 0, 1, 2, 3, 4. None of the x values repeat, so we can know pretty quick this is a function. But if I wanted to not be a function, then I could say maybe 4 and 15, okay? Well, then in the output there, you would need 15 right there. But what would that do to our mapping? It means that you'd have a second arrow coming out of the 4 right there, because you'd have the ordered pair 4, 10, and then this other arrow would show 4, 15. And so then I would know that it's not a function. So really all we're doing with mappings, and that's the nice thing about mappings, they can tell us pretty quick if we're looking at a function. When are mappings functions? When each x value or input has only one arrow coming out of it. Okay, because remember, like this one, as soon as I had 2 arrows coming out of 4, this was no longer a function. And keep in mind that where it points doesn't matter. So if I change this 415 into like 4, okay, the arrows can cross like this. Oh, very good. Like this one. But the arrows crossing doesn't matter. It's how many are coming out of your inputs on the left column there. So find the domain and range of the following mapping. Is it a function? Now, you'll see this with functions. Sometimes they're not always mathematical, so they're not always numerical like this, okay? But it's still possible to list your domain and range. So our domain here, oh, that was bad. S and then a 2. So I'm looking first at my X values. That's my domain, and I've only got an A, a C, an E, and a G. Okay, so A, C, E, and G. Now I can close this with some fancy brackets. There's a 2, there's an S. Boom. Okay, how about our range on this one? Well, the range, a little bit bigger, I guess, but the first value I see on this one is -5 and then 17. So I'll list these -5 and 17 like this. And then the next one, bacon. Oh, I do like bacon. And then the next one, 2 plus car. I don't know what the crap that means, but there it is. And then finally, -ZZ. But not ZZ top. Okay, so -ZZ. And that got kind of caught up there, but now I can close off these brackets, okay? So a little sloppy in here, but hopefully that's okay. And finally on this one, is this a function? So going back to the mapping here, we're just looking for any of these X values that have 2 arrows coming in. Yeah, there's the Y column, by the way. And there is, CE right here, it points to bacon and also 2 plus car. So this one, just from this double arrow coming out of the E, not a function. Okay, how about this one? Maybe I'll give myself some more space there, but domain first. S and then a 2. All right. Well, now I got an A, a C, an E, and a G. All right, so A, C, E, and then G for my X values. Let's close that domain with fancy brackets, X values. Then we got the Y values, but this one's changed just a little bit for my range on this one, right? Hopefully I can fit it, but we got -5, we got 17, we got 2 plus car, and we got -ZZ. So that's all my range on this one. But now I see this one now no longer has the E, this line coming out of the E right here. So there's none of these X values that have 2 arrows coming out of it. And remember, this crossing business right here, that's not going to determine if you have a function or not. What it does is if you got double arrows coming out of any of these X values, there's not. So this one right here now is a function. Well, how did we make that a function? By the way, this is pretty much the same problem as the last one we did. We took away the bacon. Oh, that's kind of messed up. But if you take away this one that you had double arrows pointing to, then yeah, then this can become a function. All right, now we've seen this already. That's the vertical line test, the one that we saw. You're just scanning the graph looking for any time that a graph can cross your vertical line more than once. Okay, because if it does, then it is not a function. It needs to only be touching that vertical line that we're going to be testing with once, and only once, in order for it to be a function. But if you ever have 2 or more places that it's touching that vertical line, then it's not a function, okay? So please try not to overcomplicate this in your head, because that's usually the biggest problem that we see on this. So here's a vertical line, right? See if I can, there we go. Got my vertical line, and I'm ready to scan this thing. I'm not gonna go that fast, but I'm gonna scan this for now, and I'm just looking for any time that that blue line is gonna touch the green line, my vertical line, more than once. At any time. And I didn't see that it ever did, right? So you can kind of see that wave as you scan this, but it never touches that green line more than once, okay? That would mean that this one is a function. So again, with graphs like this, it really is that easy in order to determine when a relationship is a function. Okay, so let's try it again on this one, all right? And I think some of you guys know where this is going, but here's my vertical line. Let me grab it. There we go. All right, so scanning left to right, right to left doesn't really matter, but I come to the edge of that circle. You could say it's touching once there, but the moment I move in there, see, even just this far, boom, it's touching here and here, right? And if you moved it even further to the right, over here, again, you'd be, that circle there is touching it in 2 spots, which means this one right here, not a function. So this is the vertical line test. And yeah, I'm showing it in 2 different spots, but you only need it to happen in 1 spot. Right? It's touching this vertical line twice, once. So I'm showing this that you can continue if you'd like, but both of these would make it not a function. All right, how about this one? This one's a pretty curvy line. Let's try this one out, okay? So here's my vertical line. Let's test it out. Okay, so I'm going to scan this. I like to go left to right, but you can go right to left if you'd like. So just kind of, and it looks like it's touching more than once just because of the thickness of the lines. But the further I go here, the more I can see that it's not touching this orange line more than once. So this one right here, a function. All right, so that brings us back to the objectives. I can determine when a relation is a function, and we saw that with mappings, tables, graphs, and ordered pair sets. And also we need to be able to determine domain and range of a function, or even a non-function, I guess. So it's more like a relationship there.